Yeah.
Yeah.
Okay. So we're getting pretty close to the end here, right? It's taking a little bit longer than expected, but I think it's still pretty good progress anyways. Um, Next problem is saying a rocket is being launched upwards with a tiny piece falling off at a certain time. So again, let's call T naught and V naught to be the time where it's taking off. And let's let T1 be the point where T1 and maybe V1 are the point where it falls off. And let's maybe let T2 and V2 be the point where it touches the ground. This problem is almost identical to that other problem we saw earlier with the, well, it was basically the same thing with a rocket lifting off and a canister falling, right? But I think the variables that they give you are just a tiny bit different because they don't tell you what the acceleration is. They just tell you a rocket is launched straight up with constant acceleration. You're told that 4 seconds. So if T naught is equal to 0, T1 is equal to 4. A bolt falls off the side of the rocket, and then T2 is equal to, or instead of using, exact numbers, they'll just tell, I don't know, like maybe 5, and T2 is like, it tells you another couple of seconds later, let's say 6 seconds later, is equal to like 11 or something, right? So this problem, you basically know all the times, and it's asking you to find the acceleration or the other quantities. And, that's not that crazy.
We only have time.
Yeah, you only have time. Interesting. So that makes me think that, okay, that does change things a little bit. Maybe it would make the delta y equation a little bit more relevant because v naught t1 is 0 minus 1/2 g t1 squared. So this relates delta y, which is, maybe let's call it y1, the height at which it achieves when it falls off. And keep in mind that it's still going to be going upwards for a little while, right? But okay, that's one equation and two unknowns. Maybe we can solve this, set this up a little bit more. I guess minus y1 is going to be v1 times t2 minus t1 minus 1/2 g t2 minus t1 squared. Okay. So this introduced yet another unknown, right? So at this point, y1, v1, and t1 are all unknown. But we should be able to get a relationship between some of these, because the velocity at that point in time is going to be related to the stuff by acceleration. Yeah, so that's just going to be, oh gosh, this is kind of hard. y1 is equal to 1/2 a t1 squared, and v1 is equal to a t1. Okay. I think that's it. Because once you plug in for y1 and for v1, at this point your only unknowns are acceleration. Oh, I'm sorry. We do know what t1 is, right? We do know what t1 is.
So will like the acceleration be like a time?
Yeah. Yeah, acceleration will be
kind of weird.
Sorry, what?
Oh, it's kind of odd.
Kind of odd. Sorry, what do you mean?
So we only have one known, which is time, and I guess we use one of the equations to like algebraically manipulate the equation so we could get acceleration only using time.
Yeah, no, I see what you're saying. Right? We plug this in over here and yeah, weirdly enough, it kind of feels like we're done, which makes me think that I must have done something wrong. Because a rocket is launched straight up with constant acceleration, right? So that sounds like initial velocity is 0. Oh, I'm sorry. These are the exact same equation. That's why. this and this are the exact same equation. I'm just having a brain fart. So you can't plug the exact same equation back into itself. That tells you nothing. So let's ignore this. Okay. Sorry about that. But it looks like this is actually a legitimate thing. We could maybe plug in V1 over here. And at this point, yeah, I don't know why I wrote 1/2 g squared. This should be 1/2. This should be 1/2 at squared. My bad. You see what I mean? I accidentally assumed that it was accelerating under gravity, which makes no sense. It's accelerating under the jet fuel with some constant acceleration. But once we plug this in, now it becomes a system of two equations with unknowns a and y1. And at that point, it becomes perfectly reasonable to solve. So problem wasn't that bad. I just made a total brain fart and wrote things out in a... Sorry, I wrote gravity instead of the actual acceleration, which is why we got confused. Does that make sense?
Can you rephrase it a little bit?
Sure, yeah. So really, I'm just going to erase this a little bit, right? There's just really two equations relevant here, or maybe three. But y1 is the height it achieves. The height the rocket achieves after some t1, right? After however many seconds it takes to get up. However many seconds it takes for the canister to fall, that's just 1/2 at squared. Yeah? It's one of your basic kinematic equations. It was the one that you said was the most common one earlier. And then on the way down, the canister is basically going to fall a height of minus y1. It has some initial velocity from the rocket's acceleration. But other than that, it's just going to fall towards the ground according to this equation. So the only thing to do here is replace v1 is equal to a times t1. And once we have that, let me just maybe rewrite it, a times t1. And once we have that, the only unknowns are a and y1. And we can solve. See that?
So initially we need to find y1 first, then get...
You can do that if you
A.
want. Two equations, two unknowns, you can solve them in either order. But the bottom line is that it's asking for acceleration. You see what I mean? Like if you had a plus b is equal to 10 and 3a plus 2b is equal to 5, you can solve for either one first, right? It doesn't really matter. At the end of the day, you'll get answers for both.
Yeah, okay.
Yeah. Gotcha. Sorry, that one was on me. I overcomplicated a little bit because I wrote the one equation out a little bit incorrectly, and it led us down a straight path. But, when it comes to physics, you can always sanity check yourself. The fact that it was... the fact that earlier we had y1 is equal to minus 1/2 g t squared didn't make any sense at all, because that means that the rocket would have been going into the ground, which would be catastrophic, right?
Pretty much.
Yeah.